How'd y'all do number one? For number one, I think what you can look at is I'm not even sure what to look at. So okay. So for recurrence, there's only 2 notes for recurrence? Really?
I'm like, for real?
Oh my god. Well, okay. Let me show those. There. All right. So oh god. So many tabs now. Wait, what? Wait, recurrence is gonna be on there? Are we sure? Yeah, never mind. Yeah. Okay, so for this one, does anybody know how would you explain it? I guess.
I can't explain it, but I guess I can show it. I'm
Go
not even
for
sure
it.
if it's right.
Go
I guess
for
I
it.
screen my thing. Hold on. Maybe I should screen. See this or not?
Yeah, I see it. So that was 1A, I think.
The one is right beneath you.
So you did induction. Oh wait, we're supposed to use induction, right?
Yeah, I think that's what he said. Hand use induction. So that's your friend.
Yeah. Okay, so you did induction. So what I don't get about induction is how you decide uh the basic step and the hypothesis. That's the two things I
Isn't in the currents, isn't it like f of 0 is also 1 and f of 1 is also 1? But
what?
isn't it how you start off in Fibonacci sequence? F of 0 is also 1, f of 1 is also 1.
I'm not sure, but I wouldn't know. It's the thing. Mm, okay. So you said you have to assume that f of 1 is 0 and f of 2
F
is
of 1,
0 as well?
f of 0 is 1 and f of 1 is 1. And f of 2 is 1 or something like that. 3 is 2 and then f of 4 is,
Okay.
it just keeps on increasing.
So f of 1 is 1. F of 2 is 1. No, f of 2 is 2, my bad. So it keeps increasing. Oh, is that because of this? Right
Yeah,
here?
the little thing he gives us, yeah, f of 0 is 0, f of 1 is 1.
Okay. Okay.
Now I actually had I don't know if you know about CSMC, but I had one of the guys from there help me on this one. That's how he
Oh, what'd he
explained it.
say?
Dude, I did it a long time ago.
Oh, okay. I mean, do you think you can explain what you did over here? First one?
I mean, obviously, I guess you do consistent. Since it's an equation, right? It's like one equals the other. So I guess I
Hmm.
just do right hand side, left hand side because that's the basic step. And then I guess in the question it said, where can you put the question on your screen? Please?
Yeah.
It said, prove that summation of n I equals 1 f of squared f of I squared. Okay. When one. Yeah, because I have one. Maybe one because summation starts at one base case. Yeah, both basic cases are one. But then you just assume for if n is greater than or equal to 1 because it starts at 1, so just like 1 up that. And after that, I just for that, I just kind of just like substituted the base case or like the inductive hypothesis in the equation and kind of just solved it out from there. That's literally kind of what it was. I took a part of the question and then added on the induction hypothesis and then kind of substituted that based on what I already had, and then I kind of got the answer. F of n plus 1 is times f of n plus 2. That's kind of what it was. Basically, basic algebra, I guess. That's the best way of describing this.
Okay, perfect. So, and for number two, I assume you did something similar, right?
Yeah, it's because given that it said that n is a positive integer, so you can't be negative, obviously. So yeah, basically the same thing. Just one equals the other, and it kind of solved it out there.
Okay. All right,
Left hand
perfect.
side and right hand.
Okay. Does anybody have any questions about that? All right. Okay, so for number two,
Also,
this
just like
what's
this
it?
little in the question, you know how it gives us that f of 0 is 1, f of 1 is 1. I kind of
Yeah.
just use that in my in right here. Whereas where I say f of 0 minus f of 1 plus f of 2, I substitute those numbers in that he gives in the question. 0 is 0, f of 1 is 1, f of 2 is also 1. I substituted those. That's how I got, like, on the left hand side. That's how I got like all zeros, and then that's how I was able to equal that to the right hand side. So that's where I got those numbers from. Anyone was
Okay.
wondering.
Okay,
Same.
perfect. Okay. So, anybody have any questions about that? Anything like that? No? Okay. So for number two, I remember the stairs one being pretty tough at first, I think, but I'm not sure. Let me look at what I have. There we go. Okay. So I remember him giving a hint for the stairs. I can't remember specifically. But yeah, right here. So this is what I use for to get the proof sort of going. I don't know about y'all.
I use the same thing. It was just s of n minus 1 plus n minus 2, n minus 3. Because in this case, we have three different cases, right? Because it takes
Mhm.
like one step, two step, or three step. So it's just n minus that number and just add it all together.
Yeah. And then for B, we just for 8 steps, how many is there for a person to climb 8 steps? So for that, I think we just plug it into this pretty much, right? Is that what you're supposed to do?
But for part B, it says how many were there? 8 stairs. I just have to list out each, like, how many ways there are to climb 1 stair, 2 stair, 3 stair, all up to 8 stairs. I think that's what it is. Because I have a little chart on my end where it says, like, if it's 0 stairs, this is how much it takes. If it's 1 stair, how much it takes.
Ah, okay. So yeah, the chart would probably be the best way to do it because this is what he had for his right here. That
C4 equals to.
C4, then C5, then C6, C7, E8, and then he just pretty much went from there.
Huh.
Yeah.
So
So he
you
didn't.
add on the previous number, the previous two numbers to your current number, basically.
Mhm.
So if you want to get A, you add on the last 3 steps to get 8.
Yeah.
Oh, that's what it was.
Okay. So, all right. Anybody have any questions about that? No? Okay. So for problem three, I guess, yeah, you're supposed to use strong induction. So with strong induction, I get a little even more confused because strong induction, you're supposed to do something wild and wacky, which I
Same for
don't get.
strong, you just have multiple cases to kind of just show that, like, it's like out of all this range, like this range of cases you can use, you have this specific case that's works for this. And that's what strong induction kind of just like comes down to, you know.
Okay. So, but that's but in the solution, he didn't do multiple bases. But I mean, I guess this would be considered multiple bases, I suppose. I'm not sure. But see, this is what I mean. I don't get the hypothesis. So how do you get k minus 1? Why is it not k plus 1 or something like that?
I think he said that you can use either or, k plus 1 or k minus 1, doesn't matter. It doesn't really matter. Because remember in class, sometimes you would use k plus 1,
Yeah,
and, and sometimes you k minus 1. He said it doesn't really matter as long as you can like come down to the like
to the what?
it's in thing. It
Um,
doesn't matter how you get down to the conclusion. You can either use k plus 1, k minus 1, because they all would lead to the same answer eventually.
okay. I guess think I see what you mean. So Lotus also said the strong induction part is for all A, B
B
part.
part. It's not IH, I think.
So right, okay. Oh, okay. So for strong induction, you basically base case you just assume A and B, which are zero from the beginning, and then in the hypothesis, you just say A and B can be any number whose sum is divisible by 5. So pretty much you just assume A and B are two numbers that go for infinite,
Yeah, I
and
mean,
then you
aren't they
use
supposed to do? When you add them both, they are divisible by 5.
because
I
you
guess the
end
way
up
I proved it was a little different, but I guess he still gave me points for it because I said that like to form a plus b, where a plus b is divisible by 5, do a plus 2 b plus 3
mhm,
on a minus 2 b minus 3, or a plus 3 b plus 2 on a minus 3 b minus 2, because like you have to add both of them to get and divide it by 5 for you to actually prove that it's divisible by 5, right?
yeah,
So I I guess it makes sense based on what I wrote too, but oh well.
yeah. Okay, so for number 4, does anybody have a good grasp on how to do number 4? Because I mean, honestly, I'm just running this thing. I don't know how to do it half of this stuff that's on here. So I'm sorry, but yeah, guess not. But okay, so for number 4, give a recursive algorithm for computing NA, where n is a positive integer and then a
Oh
is a real
oh
integer.
yeah, I know this. It's just you basically coding it out. That's basically what it is. Yeah, it's just writing a pseudocode for this. Yeah,
Is that
with
it?
Lotus.
Is that
Yeah, it's
all you're
just writing
doing?
a pseudocode because it says give
Oh,
the recursive algorithm, right? And then in the example in class, the recursive algorithm was a pseudocode he showed. So I literally just wrote that down. I just said that if f of n equals a and a to the power of n, where n is greater than or equal to 1, and then I basically kind of wrote what he wrote out: function n will comma a if n equals 1, return a, if then n minus 1 comma a times a.
oh, okay.
Fine.
I'll take y'all's word for that. So yeah, that is literally what he wrote. So you're right.
She's gonna, I don't know if I remember if I read that thing. He's gonna,
I got the word.
I mean, who knows at this point?
I don't know. Honestly, I mean, it says one thing and then another thing happened in the test. So okay, for graphs, I definitely know a lot. So for graphs, I think it's pretty simple. I'm not sure if we should go over them, but we can.
I mean, for when it for like something like when it's for bipartite, I don't know if everybody used this example, but like the two colorable example.
Yeah,
Is
that's
that the
probably the
only?
best one.
That's my best one. Yeah, that's what I use. I was able to get that one. To one for question one, I was able to get that down. But for
Yeah.
question two, I actually got that one wrong. there's a question. Let me see. Where did it go? Assignment homework 6. 2A.
So
Question
this one,
2A.
you got it
Yeah.
wrong.
Yeah, I said it was not isomorphic, and then I didn't know because what I was thinking was that like, okay, you know how like U1 has to map to V1 and U2 has to map to V2, like they have to correspond
Oh,
numbers. I didn't
yeah,
know like it could be U1 could be mapped to like U5 or V5, you know?
yeah,
Like
yeah.
I didn't know that. I thought that the fact that like
They
you
had to
know
be the same.
yeah, that's what I got. I just said it's not isomorphic, but it doesn't contain equal number of edges. Because on U3 you see it has 3 edges, right? And
Hmm.
then in V3 only has one. So I didn't. That's why I got that one wrong. But I guess now I know that it can be mapped to anything, per se.
Yeah, so the way you want to look at it is that they're not necessarily the same graph. They're basically two different graphs. So regardless of what these vertices are, can you make this graph from this one? That's how
Okay.
you want to think about it.
All right.
So
That helps.
basically, the way I was thinking is that if you use this number 5 as
Yeah.
your the center for as U3, so you have 1, 2 across, 1, 2 across, and then you have one down.
Oh,
Does that make sense?
yeah, makes sense.
Yeah.
And then for 4I and 4J, I said it was not M airy or 3 airy because there was neither full or perfect. Someone explain to me how you get that, honestly.
I think I got those wrong too. Let me check.
The children. But so full elementary means it has to have 3 children. If like, huh.
I think I think if if it is a full if it is a full full tree, then yeah, it must be they look like all them from the same children.
Because the way I looked at it was that like for part I, it says I root at C. So where's C? C is right there. It says is a subrooted tree at C and M married tree for some positive integer n. Nice. Huh. I actually have to revisit unmarried trees because I do not remember this. I said it was neither. I said no for both of them for I and J. I said that it's neither full nor perfect. So I said and I got it wrong.
You got both wrong, or
Yeah, for I and for J, I got both wrong. I said they're not M area or 3 area because they're neither full nor perfect.
right?
And
So
half points for both of them.
right. I think I said I think I got I right, but because I thought like so for this one, for B, I mean for C, this one, it's full because it has all its nodes have children and they're sort of even, but I has more children than H. That's the reason it's not perfect. I think that's what it
Oh, so
was.
so I guess C would be a parent in this case, and H and I would be its
It's
I guess
children.
it's children, and then their children have at least 2 or 3 I guess children,
Hmm.
right? So that's what makes it a full a married tree.
I think so. I'm not. I can't remember for sure, but
Because it's an internal vertex at this point, right? Because PQ, RST are not considered internal vertices.
hmm yeah. PQ, RST are children, so they're not internal vertices. What is going on here?
And If I fail this test because of this stupid stuff like that, I'm gonna kill myself.
It's fine.
Some tree the line rate trace the positive integer m.
Okay, so anybody have questions on graphs at all?
Proof that every tree is a bipartite.
Yeah.
I said for question 5a, I said it was I disproved it, but he said it's
Yeah.
actually true.
What? Really?
Yeah.
Oh,
The reason why I disproved it is because it says a graph is connected if and only if some vertex is connected to every other vertex. But in a graph, a connected graph, isn't it like a straight path, basically, like a walk, like a
yeah.
UV walk? But if that's a UV walk, then that means that like each vertex is connected to the one before and the one after, not every single one of them, you know? Like it says that if some vertex is connected to every other vertex. Like there's not a vertex in this graph that's connected to every other vertex. You know, that's why I disproved it by saying that like it doesn't follow the connective graphs definition. And he said that I was wrong. He said the claim is actually true. So I was surprised.
Yeah, I think I said it was false as well.
You got that one wrong too then?
I think so. Let me check. So it's homework 6?
Yeah.
Nope. I think I got that right. Never mind then.
Because I disproved it by contrapositive, I think. Yeah.
Right. So for A, I think all I did was assume that a graph has more than 2 nodes if the graph is connected. There's
So I'm
two
guessing
nodes.
that in the exam we don't have to show like like he does in his answers and his notes is like going right and then going left. You can just write a paragraph in. You should be
Mhm.
fine.
Yeah. Yeah, for so for the proofs, I think there's two ways of doing it. You could do like the like this, like
Yeah,
the step by step going one by one,
yeah, yeah.
or you could do it in a paragraph. The reason I did it for a paragraph because I didn't have any like equations or anything like that to write
Yeah,
out. That's why I just made it a paragraph or
yeah. I
two
made a
sentences.
paragraph for both of them. I think I made a
Yeah.
paragraph for all of them. 4, 5, and 6, and 7.
Yeah. 7 was kind of tricky because trying to prove it was kind of tricky because I didn't know how to start. I mean, I didn't know how to do induction, obviously. So,
No, 7. Uh, I guess I used the bipartite definition where like it can be divided into two sets V1 and V2, where each edge goes between vertex V1 and V2. So I guess you could assume. I kind of make an assumption basically, because if you look at question like question 4, right? It's like question part root A, vertex A is basically the root of the whole tree, correct? And then after that, it's like levels. Like A is on level 0, B and C and D are on level 1, E, F, G, H, I, J, K on level 2. So it's like
yeah.
every every odd number level is connected, and every even number level is connected. Because you can have a path going from like level 2 to level 4, because you connect to level 3. You know, in a way.
Mm,
That's kind of how I proved it, and I said that it can be every tree is a bipartite. And
yeah.
that's how I kind of said it, because levels 2 and 4 will be in the same vertex in the same set, and level 1 and 3 will be in the same set. You know.
Yeah. Oh, and for I remember number 6 giving everyone trouble because we didn't know how to start it.
Verse 6 was. Oh
This one.
yeah, that
This
one.
one.
I was a little confused about that too.
Yeah.
I kind of just went with the equation for that one. For 6a, I just said that like a summation thing. The average
Yeah.
degrees of E would be 2 times E uh over, which I guess basically 2 times M over V, because E
Mhm.
is edges and V is vertices. You know.
Yeah. That's what you're supposed to do. as far as I
Yeah.
know.
But part B kind of just like I was a little confused about it.
Yeah, part B, I had no idea. I don't even know what I wrote here.
I use the same thing too, where 3 minus 6n. I guess mine was 3n minus 6.
That's 3n minus 6.
Oh, that is 3n minus 6? But
Yeah.
the other one after that is less average, is less than equal.
Oh,
Yeah.
right here? Yeah.
Yeah. Oh, what are you doing over there? You just kind of like flipping it
Dude,
over?
don't ask me. Don't ask me. Don't ask me. I have no idea what's going on there.
Yeah.
I think what was supposed to happen is you divide the entire equation by n, but then I just divided 6 by n for no reason,
Yeah.
and that somehow worked.
Thing that you ever planned.
I don't know what happened. I must have blacked out when I wrote it, honestly.
So I guess we can assume for this question for part B is that like it says that use part A to prove that every planar graph has a vertex of degree at most 5. So we're assuming that it has a degree. There is a vertex of degree 6, which we can make the assumption, right? And then the current degrees. Okay. I guess the way I proved it is a little different. It kind of the same thing. But let me just show it to you what I did. I don't know if it's gonna help or not. Because
Right.
I said that given that we have this equation of m is less than or equal to 3n minus 6, and the average degrees is basically 2m divided by v, so we can assume that a planar graph has at most a vertex of degree 6, because it's telling us that there is a graph that has a degree of at most 5, so we can make the assumption that there is a vertex out there that has a degree of 6. So then we can just we can kind of just like substitute it out and kind of divide it out. And then because 3n minus 6 is less than 3n, right? Oh, no, I'm sorry. Yeah. Yeah, right. Yeah, it is less than 3n.
Yeah.
I guess I said it's contradiction because that's how I proved it. But I'm not really entirely sure if anyone else did this way. And
I mean, hey, as long as it works, right?
yeah. Yeah.
Oh,
I'm actually curious how we're studying for this. Like, how we're going to study? Like,
I don't know.
just learn the concepts, I'm guessing, and definitions.
Maybe. I mean, I guess.
Say for the internals, just excluded.
Okay, so I don't know if we should discuss number 7 because I haven't even started it, but if y'all want to discuss it, y'all can. Like, I just started 1 right now, so I have to get
I guess if
started.
you do want to discuss homework 7, you can go to study room 2 and then kind of just like oil out
Yeah, for homework 6.
with the internals, exclude it, exclude the
Yeah. Yeah, Lotus. I think so.
Damn, I get flowers. My guy said check textbook and Google.
Good luck with that. Blackout.
Did you use induction for question 7 on homework 6?
For number 7,
Yeah.
I did, but I found something online.
Oh, because I didn't use induction. I just wrote a paragraph for it, and then he took off 4 points for that. I was like, oh no, he took off
Oh,
2 points for that. I was like, thanks, I appreciate that.
that's nice. I mean, at least you didn't take off all your points, right?
Yeah, I mean, it did have like I did prove the fact that like it's true.
Yeah.
Something I'm literally, yeah.
Homework 6. Yeah, I think I found something online that helped me a lot.
Sure.
So for number 7, that's how I wait for number 7. This one.
Yeah. For the
Oh,
induction.
right. I didn't find something online. I found something online for number 6, but for number 7, I just pretty much assumed that there's 2 trees with 1 and 2 nodes, and then
One,
use those pretty much.
suppose as less than a vertex input. Okay. One. Oh, okay. I think you'd actually grade these. Like, I'm actually curious.
I feel like he didn't because for number 6, I literally don't this makes this string of words makes 0 sense. Like I don't know how you go from A AVN divided by 2 equals M to N equals less than equal to 5. I don't ask me how I did this. I don't know what this is. So, and I got full points for this. I didn't even get this question wrong. I got some other question wrong.
Now, question 6, I got 4 points too. Question I got 4 points too.
Maybe he might have just left this question out because everyone was having trouble with it. I don't know.
Could be. Let's hope he's gonna give a question like that on the exam.
Yeah. So, okay. What is the Hass diagram?
It's just interesting. I think he has it as the notes. It's like the notes from the notes will help you better understand it. It's like,
Second one on relations.
yeah. The hash diagram just kind of makes it yeah, right there.
Right there. Right
So
this.
the go a little up, that page that yeah, right there where it says in red, remove blue, reflexive. It's
Mhm.
basically a simplified version.
Oh, that's what he
that.
was talking about. So this is the
Yeah.
day I walked in like half an hour late, and I was like, what is
Yeah,
going on here?
the hash diagram is like a simplified version of like the diagram above. So that's basically what it is.
Okay. So what you're supposed to do is just basically make this. Do you always have to make this? Like
I mean, it's going
3
from
going
like
from
highest
down?
to least. Yeah,
What do you mean?
what blackout said, basically.
So highest
So that
degree
equals
minimal.
to the minimal element and low degree equals to max.
Okay, so wait. So this is a tree that's going down, right? Or tree going up.
Going down at this. I guess it's connected. That's kind of what it is. Because like if you go up, you look at the diagram above, like it has all these loops. Because you're
Yeah.
kind of basically proving that it's reflexive, transitive, and anti-symmetric, right?
Hmm.
So basically, this diagram is you're basically making all those like lines going from point A to point B. The hash diagram kind of just like shows it that it's that, and you assume that each thing is it's reflexive on it. It has like it's reflexive on its own, like each vertex, each like I guess in this case.
Okay,
Okay.
I see. I think I get what you mean.
Yeah.
But what I don't understand is like does the shape of the hash diagram always have to look like this?
No, I mean you could look at anything. Like look at the question 4 in the homework. Like that's a hash diagram.
That's a hash diagram? Oh,
Yeah,
it is a hash diagram. Right.
like it
Okay,
doesn't
so
matter how. 'Cause as long as like you're going in like in a pattern the way it's supposed to be. Like
Mhm.
A is the root of this whole thing, right? And
Yeah.
B and C are connected to it, and C and F and G are connected to C. G is connected to D and E.
Okay.
Yeah. I don't think he's gonna make us drawing hash diagram on the exam. Like that's highly unlikely. It's
I
gonna be
I
all
doubt
good.
it too because it seems pretty simple.
Maybe he might ask like the questions like the maximum and minimal elements. He might ask those questions,
Hmm.
but it doesn't make a dot diagram. Like that's just very that's redundant.
Okay. Okay, so right, maximal, minimal stuff right here.
Mm-hmm. But I got a little trick, a cheat sheet about maximum minimal
Hmm.
and the thing. It said that highest degree it equals to minimal element, lowest degree bottom to max. Maximum equals lower degree, greatest equals to first middle.
Then we have matrix C's. Okay.
Question 6, I don't get right now. I honestly, question 6, I don't understand it at all. I was lost on question 6. Prove that's the equivalence. I think that's to prove that's reflexive, symmetric, and transitive, right? That's equivalence relation. Am I right?
I think so. Sorry, I wasn't talking to my mother. But you're saying what?
For a relationship to be equivalence, it has to be transitive, reflexive, and symmetric, right?
I think I have no idea.
Yeah.
Yeah.
Yeah. Thanks, Lotus. I'm just asking because like I think I have a way to prove this, but I'm not. Then part B is like find 1,5. So I'm just like,
Bro,
what the hell is that supposed to mean?
I have to get this home. I have to get this homework finished. I I just started, so I gotta get going. Well, that's all I have for the study session for homeworks. I mean, if y'all want to stick around and do something, you can, but I'm gonna go try finishing this homework. Okay. Well, I'll see y'all later, all right?
For the day.
Yeah, I think that's it for the day.
You're not doing
I
it
mean,
together?
the homework? Could, if you want. We can. I feel like that's got a bit of cheating, but that's fine. I don't care.
That's the last two.
And bro, it's the last 2 weeks. Bro, scholastic dishonesty. It's gonna haunt you. No, I'm kidding. Yeah, we could do it together. I just started, so if y'all want to talk about anything, go ahead.
That's props. Okay. I mean,
So wait, actually, may as well do it together. So for one,
yeah.
so when you're doing B, you go
Yeah.
from AB and then BA. That should be AA, right?
It,
So
they
AB,
go from
BA.
yeah, because in this case R would be considered A, and then S would be considered B. You go from A to B.
Yeah.
Yeah.
So you do that for all of them, right?
Yeah. I guess you do that for every single one. You can find a relation too.
Okay. And then so since S has more elements, do you include the one that's the odd one out? I mean, I guess.
Yeah, I think you do because it's the whole thing. I'm guessing you do. I mean, I did. I did. I texted one of my friends. He said that we got the same answers. I'm just like, okay, cool. Like, I guess I'm not
Hmm.
wrong then.
Okay. Because for B, I have AA, BB, CC, DB, and then DD
Yeah,
again.
say that again. A B B.
AA, BB,
Yeah,
CC,
yeah.
DB, and then
D D
DD.
D D. I have that too. Like all those, including AC and CA, which I guess is the same thing. Because I got AA, AC, BB, CA, CC, DD. That's what I have.
Oh, so wait, are you supposed to compare it to every single one? So you do AB, BA, and then you do AB, BC.
Yeah,
You do for everyone.
I'm guessing.
Is that how
Because I
that
was looking
works?
at his notes. He kind of did that. That's how I understood it as.
These are
Kind
the
of did
only
it like
notes these are the only notes that I saw, like
yeah. That's the
literally
only
right
thing that
here.
he has on there too. It's just kind of stupid.
Yeah. So I don't
Because I
know.
guess he's just multiplying R by R. I'm going down. Good luck with y'all. Thanks, Lotus.
Thanks,
Good
Lotus.
day.
We'll see you later.
See you Monday. 24 hours.
Yeah.
But yeah, I think yeah. Because like if you look at the example, right, it says R squared is R to the power of one with times R. So this is what I don't get. How did he come up with this example, bro? Like that's just oh
Yeah.
he just multiplied it within the set of its own. So 0, 1 and 1, 2. So that's 0, 2. And he does 1, 2 and 2, 3. So that's 1, 3. And then he takes 1, 3, right? And he goes it by 3, 4. That's how he got 1, 4. And then he does uh 1, 4. Okay.
Oh, so that
Yeah.
yeah, you guys are right. So he went from 0, so he did R2 times R is 0, 2,
So he took the
0,
first two
2.
pairs.
Yeah, so
He
0, 2
got 0,
is
2.
0, 1, and then 0, 2 over here as well. So 0, 1, 1, 2. But 1, 2 is not in there, is it?
No, so
Yes.
he took the first two pairs, he got 0, 2. He took the second two pairs, he got a 1, 3. And he took the way I'm understanding this, he took that 1, 3 pair and he did it 3, 4. That's how he got 1, 4. He already has 2, 4, right? And then 3, 4, he got it by taking the pair of 3, 4 and 4, 4. That's how he got 3, 4. And then
And then
Yeah.
4 4 was just completely left out, so he included in everyone.
See, this is how. This is why I don't get. How do you get that? That's like what gets to me.
On 3,
What part of 3?
I think he's confused on how to even start it. To
Oh,
be fair, I have no idea.
because n isn't n considered natural numbers? So natural numbers, I guess, forget problem 2, right? Natural numbers are all like positive integers, so 1 starting going up all the way, right? So given that it says maximum elements, like there can't be no maximum element because in the given statement it says that a1 is less than or equal to a2 b1 and a2 is equal to b2. So like they're all either greater than or equal to their respective, uh, I guess set in this case. That's why there wouldn't be any maximum elements, but the minimum elements could be 0 0 because the most least element in this case would be 0 0. You know, same thing with part C and D. There's no greatest element but there will be a least element, which would be 0 0. Because by definition of greatest and the maximum greatest element, it's isn't it like what's the definition? It was any element u such that there is no element greater than u. Like that's for maximum elements, right? But given the definition, it says that a1 is less than or equal to b1 and a2 is less than or equal to b2. So there's that just gets like disproved right then and there. Because if they're all integers and they're equal to or less than equal to, then they're gonna eventually equal up to each other, right? That's how I understood it as. So that's why I said that part A and part C there's 0 0. And then for part B and part D, I'm sorry, part A and C, I said there are none. Then part B and part D, I said that there's 0 0. Hope that made sense.
It does. Thanks.
Has anyone in here done question 6 by any chance?
I mean, I'll stop streaming so y'all can share your stuff too. You need
I did I did question six um for that what only one person has been the same. No nigga thing to satisfy this equation. Does that make sense?
Yeah, it makes sense. Appreciate it, bro. I'm gonna call it a day, boys. I'm gonna go work on question 6, and then I'll see what I can do.
Yeah, me too. I'll see y'all later.
Yeah, bro.
Good luck.
Hey, you too, bro.
Thanks.
I'm gonna to bye guys.